this session we are going to look into the next part of the pre-processing, that is discretization. So here we are going to look into the importance of discretization, the transformation principle, and the different techniques that we have in case of discretization. And today's session will be discussing mainly on the unsupervised technique of discretization. So when it comes to discretization, so why this discretization becomes so important is sometimes when the data mining algorithm used for the analysis purpose requires the data to be in the categorical format or as a categorical attribute. If the attribute given to us is not in that particular format, then in such case to transform the given attribute into the categorical format, we will be using the discretization technique. So when I consider this with respect to a feature selection, we can tell that best discretization approach is the one that produces the best result for the data mining algorithm that will be used to analyze the data. So that is what is the discretization importance is. So now as the definition says, this helps in the transformation of continuous attributes into a categorical attributes. This is typically applied for those attributes which are used in the classification and an association analysis. So achieving the best possible discretization depends on two things. One is the algorithm being used, and the other thing is the attributes considered. So when we say that transformation is happening here, the question arises, or the question that comes to mind is, what is that transformation and how is that done? Or how the transformation is being performed. So here the transformation involves two subtasks. One is deciding how many categories that we need to have, and then determining how to map the continuous values to these categories, because as I told earlier, we might have an attribute values other than the categorical type, so we have to map it to the categorical type. And here we also have to consider how many categories do we need for the number of attributes that is given to us. So this is what is called as transformation principle. So now this transformation principle, it is done in two steps. In the first step, as in first case, what we do is we have to do two things here. First thing that we have to do is we first have to sort the values in the continuous attributes. So either you sort it in the descending order or ascending order, any one particular order, we will sort all the n values given to us, and then we divide these sorted values into n intervals. So when I say we are dividing it into n interval, obviously any data set you take, when you are dividing a particular data set given or the data values given into n intervals, which means we will be using n minus 1 split points. So as in this case also, we will be using n minus 1 split points. Okay. In the second step, what we are going to do is we are going to assign the categories. So that is in the second step we will be doing. So here, from the outside view of this particular transformation principle, it looks very simple, but actually there is an issue here. So what is that issue is, so how many split points we have to consider? That is the first issue. And if at all, if you are considering the split points, where are you going to place those split points in the given objects or the given data values? So these are the two important issues that we need to address. Once this is resolved, what we can tell is the final result is represented as a set of intervals or a set of inequalities. So this is very important with respect to the transformation principle. Okay, so once this is sorted out, we can tell that discretization can be performed in two ways. One is the unsupervised mode of discretization, and then the second one is the supervised mode of discretization. So as I told earlier, we shall first look into the unsupervised discretization mode. So how is unsupervised discretization is performed? Okay. So as I told earlier, since this is we are going to apply this discretization mainly on the classification as well as the association analysis. Here I am going to consider the classification process to explain what is the unsupervised mode of discretization. So with respect to classification, yeah, it is true that we are going to learn this classification as a separate module, and in detail we'll be learning about that. So here I'll just give a brief description about that. So in case of classification, what we have is we'll be having a particular model. We will build the model. We will have a data set. that data set will be taken into the model, and the output of the model will be dividing the data set into different classes. So when I say unsupervised mode, class information will not be given. If I say supervised mode, class information will be given to us. So now we are going to consider that mode where we don't have the class information prior hand. So how are we going to do that? So we have two different approaches here. One is equal width approach and the other one is equal frequency approach. So let us first consider equal width approach. So here in this approach, the attribute values are divided into user specified number of intervals having same width. So you are going to divide the given data set into a number of intervals specified by the user, and these intervals are having same width. That is the thing. So let us before we move on, let us try and see understand a few terminologies or two few variables. First one is k. Here k represent number of intervals, and these number of intervals are specified by user himself, and w is the width of each interval, where the width size must be same, right? So to find the width size or width interval, what we are going to use is we are going to make use of a formula, that is w is equals to max value minus min value divided by k. So what is this max value here? It is represents the maximum value in the given data set and the minimum value for that particular attribute. Since I'm considering a continuous attribute and that too in a sorted order, so the maximum value and minimum value we'll easily get from that particular sorted order, and that particular thing is going to that value is divided getting divided by number of user specified intervals. So with that I'm going to get the width. So let us take an example. Suppose consider this is the data set given to us. So I think this is already in a sorted manner. If not, we have to sort this. So it is actually sorted, and he is telling that we have to divide this into 4 intervals. So as I told earlier, first we have to find the width, right? So width will be what? Maximum value minus minimum value divided by k, and in this case, since he is telling that the interval is 4, I'm going to take k as to be as 4. So now minimum value is 0, maximum value is 39, so I can easily find the width, which will be approximately equal to 10. That is maximum value minus minimum value by 4, so which is equals to 10 here. So when I say the width is 10, which means that we will be having 4 intervals, and each intervals will be having a width 10. So now I'm since based on that I have to divide it into 4 intervals, right? So let the interval be since I have numbers from 0 to 40. Say let us do like this. We have 4 intervals, that is starting from 0 till 10, not including 10, but then from 10 to 20, like that we'll consider. So these are the 4 intervals that we have considered: 0 to 10. So 0 included, 10 not included, 10 to 20 where 10 included, 20 not included, 20 to 30, 20 being included, 30 not included. Like that we have created 4 intervals. Now what we are going to do is we are having 4 intervals. Say that consider that we are having 4 categories, and in the category 1, that is value from 0 to 10. So those values which are from 0 to 10, I'll be putting it in category 1. So 0, 4, 12 comes under 0 and 4 comes under category 1. And now in the second category, we will have those values from 10 to 19, 10 to 19, 20 not included. So 10 to 19, which is 12, 16 and 17. In the third category, I'll have elements from 20 to 29, which includes 20, 22, 23, 25. And then 30 to 40 we'll be having in the last interval. So this is how I'm going to categorize or convert the given continuous data into categorical data. So here categories, let me consider it as 4: cat 1, cat 2, cat 3 and cat 4, and even I can give name to these categories. So now this continuous data set is divided into categorical data with equal width. So when I say equal width, it is not about, I'm not talking about the number of elements present in it, but the size, the maximum size that each category can hold. That is what equal width represents here. So hope you have understood what is equal width approach, right? So in equal width approach, we are going to divide the entire data set or entire attribute values into the user specified number of intervals, and each interval is having equal width. When I say equal width, you please note down this: it is not the number of values that it can take, it is maximum value that each category that can take. Okay, so that will be common for how much our categories we have. So in this case it was 4. We have a formula for that, that is maximum value minus minimum value divided by total number of intervals. So this is about equal width approach. Next, let us see equal frequency approach. So here, in case of equal frequency approach, what happens is, here attribute values are divided into k groups, and this k, each group here contains approximately equal number of elements. Here, since it is equal frequency, when I say frequency here, it is nothing but the number of element that each category will have, correct? So I am going to divide k groups, and so that each group is having equal number of elements. Now consider the same example, and here again I want 4 intervals to be made, and say consider and one more thing, it is we have to keep that in mind, is it is approximately equal number. It need not be the same, it is approximately equal. Each category should have approximately equal number. So here k is 4. So what I'm going to divide here is, since there are how many elements? 2, 4, 6, 8, 10, 12, 14, right? 14 elements are there. Yes, 14 elements are there, and these 14 elements are to be placed in 4 intervals, and each interval should have approximately equal number of elements, which means that each group will have approximately 4 elements. Any one group might have only 2 elements. Okay, so let us do that. So I cannot have 3 elements each, because it will be 4 3s are 12, but I am having 14. So let me do this. Category 1 will have 4 elements, first 4 elements. Category 2 will have next 4 elements. Category 3 will have the next 4. So 12 is done. So next the last category will have 2 elements. So with this, what I'm doing here is, so we are divided each category to consist of 4 elements. So that is approximately, out of 4, 3 is having 4 elements each. That is what approximately word approximate means here. So this is what is your equal frequency approach. So with this, we have come to the end of this session. Thank you, students.